external interrupt 0, 1, 2, 3, you have a 60 timer, there are different types of interrupt. So, so what happens if you try to trigger two interrupts at the same time? The system handler and the external interrupt 3. If you trigger at the same time, what happens?
But in order of priority.
So there's a priority setting. So you should realize that the system is the programmable, but it's the system. Inside the system. So this one has higher priority than the external interrupt. So when you are in the external interrupt, when you press switch 3, you are asking some light signal to work. But during that period, actually 60 is keep triggering actually, still counting the time for you. Okay? It has a higher priority than the external interrupt. But actually you can program it to flip the priority actually. So there are different type of priority register you can look inside, and these are 5-bit you can change. But this will be covered in detail in the lecture. So this is one example of it. If I set a priority to be 00, this is lowest number means the highest priority. I set the priority for the keyboard to be 11. So if I press keyboard in the main function, this will be the trigger interrupt. But if the timer, the priority is low, it will trigger in between them. It will override. It will, after this timer has finished, it will proceed back to the keyboard. Okay? So you will,
the lower the higher.
the lowest the highest. So that's why if you look inside your hard fork, you remember when you write some code, there's an error, right? So this hard fork is written negative by your supplier. You can never program it. It's not programmable because the lowest the high, the most priority you see, reset. You can always reset it. You need -3. You can never override anything. So you will learn more about these bits, how to adjust on it in the lecture next week or this week actually. So let's look inside how we can write it in the code. So if you have different type of handler like sysdig and external 0. Actually, you can call the priority grouping 5. These are 5 bits. And you can write how much priority you want to set here. Okay, but in our assignment, we don't need, but in the previous assignment, you have to change the priority between the external, you have to switch between the sysdig and external interrupt last time. Okay, but in this case, we still want the timer to override it. So it's not a problem. I think you should know how to write it. And then, I want to go through with a bit of the assignment with you on the one important thing. So I was emphasizing that you need to use two RGB, right? Red and blue. Have you started writing your own function?
No.
So if you look into the library file, you will realize that the RGB. So, you cannot play a song. The assignment doesn't ask you to play a speaker, right? Right? You don't need to write a speaker. You don't need to run green RGB. Okay? There are reason for that because the speaker is short-circuited with the blue RGB. If you run a speaker, you will realize that your blue RGB is switched on. So another problem is that this is connected to the OLED. So if you try to display, you will realize that your green RGB is off. Okay. And then for our case, you want the blue LED to work. That's why we don't use this. We want the OLED to work. That's why we don't use this. So if you try to open on the RGB file, you will realize that whenever you use this machine, your OLED will switch off. Okay, whenever you use this library file, the OLED will switch off because, for example, I don't want to test the green RGB. I just place RGB red inside here. Okay, you will think that it's safe, but actually it's not because you have written a code. The library file has written a code here to switch off the green LED here. See here, port 2 pin 1. Okay, because what you do here is you are setting this port 2 pin 1 to be RGB. GPIO and set low, set the output low. Okay, but what happened here is that this port 2 pin 1 is connected to green LED and then OLED here. Okay, so in this OLED, you remember OLED we are working in SPI mode. So SPI mode have a clock signal. Okay, let me go back to the briefing last week. This is tomorrow, next week, right? So if you look into the OLED, you have a clock signal here actually. This clock signal here is this thing, okay, SPI mode. And you want a clock to be working like this all the time. Because in the SPI mode, you are shifting the data in serial, one pin only. If you set this pin to be low, okay, your clock will stop working and your LED will not display anymore. That's why I will recommend you to write your own local function to display this. Okay? So if you read in the library, you can see that this is the function we use for setting up the RGB. This is the function we use for setting the blue RGB, right? So you can take from it and write your own code in the main C. Okay? But don't modify the library file. Because in your assignment, when you submit a report, we won't be reading in your library file. We'll be reading your main function, right? So if you try to change here and tell us it's in the main library file, we won't be able to break you on it. Just make your own local function for that. And another reason we shouldn't use this function is because you can only switch on one at a time, right? We want to switch on both at both same time, right? Linking for different conditions. So write your own code. But use my hints for you is you just switch it, setting the RGB pin, GPIO pin high or low only. Okay. And if you get annoyed by the green LED, you can actually switch off the, take out the jumper for the green LED. It's a jumper.
How to write the own like for the green LED?
But don't touch it.
Oh,
Don't touch this pin as a GPIO at all.
okay.
Green LED, just use the red and blue.
So you comment out the whole thing first.
Don't touch in the bind file.
Okay.
Just right here. If everything you do here, right here, in the main.c.
So don't touch the library.
Because library file will be always imported, right? So every time you import the library file, you have to be writing it again at the same time. And any other question for the assignment? What? You are this for the next week. So I think without UR, you can start working on it actually. And I want to remind here it's a 500 millisecond. You will check on this time.
How to check? Using the software.
Or in the assessment, we will read in your code. So actually, one group this morning a person was asking. Actually, I can just put in a while loop, and while loop take a long. It's a polling mode, right? It takes time to finish all the process. Then you can next round you can ask it to switch off. It's like 5 milliseconds also, but actually we can read in the code later to check. So I will recommend you to do the similar thing like the 7-segment counting, right? 7-segment counting. But the one hint here is actually your while loop might take more than 500 milliseconds because you will be writing a lot of code, right? And then temperature sensor is one of the slowest sensor because it will remember the temperature sensor change based on the temperature. If it is very hot, the width will get longer. If it is very low, the width will get shorter. And you are trying to check this using a counter. You are reading on it. So this is gonna be very slow. Why do this gonna be? So the hints for you is you can actually put this in the. I'm not going to tell you where to put. You can ask it to blink in the interrupt. The interrupt is going to trigger all the time. There's one interrupt that triggers all the time, right? So then use it. Okay. I think while loop will have an issue. It will overshot 500 milliseconds. And another thing here is I recommend you to take this out. This is the timer. Wait. This is delaying 1 second. Okay. I think there will be a mark checking whether you put a timer wait. We don't want to see this because this is a easy function for your timer. Okay, you need to make a timer by yourself. This is just a delay function. Okay, make sure you don't have this and you don't have a print function, and that should be fine. Okay.
Okay.
And start making flowcharts. So before you start the assignment, you must make your flowchart first. Because there was a case was told by the other GA that one person do the project, one person do the flowchart. So once we assess, your flowchart doesn't match your assignment.
Oh
you
shit.
lost all the grade in the report. And since most of you might be able to finish the assignment, most of the grade, the one you set the cuff, right? People who lose the most are from the report, right?
The report.
If you don't do the report, okay. So please focus on the report, okay? Report is also important.
Okay.
Okay. Any other question?
More assignment. How many percent is the enhancement? Just a bit.
I don't know the mark yet. That it's not
Not much. Maybe don't do
It's not much. It's not much.
Not much. You mean
So like, shouldn't rack our brains to think of it.
Might be
Very.
not even 5%.
Oh yeah. The answer is 10%.
I think writing your report is more important.